video is going to take a look at scientific notation. Scientific notation is most often used when we're trying to express either very large or very small numbers. When looking at a number in scientific notation, there are three different parts that make it up. The first part is called the coefficient. This is the number out front. It is important to note that this number should always be at least 1 but less than 10. We always multiply our coefficient by a base of 10, and then there's an exponent on that 10. The exponent is equal to the number of positions that we must shift our decimal in order to express it in standard notation. If this exponent is positive, that means our decimal would need to be shifted to the right, and if this exponent is negative, it means we would need to shift it to the left. Let's take a look at a couple examples. Here we can see we have a couple of very large and a couple of very small numbers. In order to express these in scientific notation, we need to first move our decimal place. If I look at this first number here, I see that in order for me to have a coefficient that is between 1 and 10, I need to make sure my decimal falls right here between the 5 and 3. So I would end up then with a coefficient of 5.362. And then I need to multiply it by my 10. And now I need to figure out what my exponent is. If I count the number of positions, we see that we would need to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 positions. So we see that my exponent is going to be 11. And since this value is large, we want to make sure that our exponent is positive. Note that if you are expressing this number on a piece of paper, this is what it would look like. However, if you were to try to type this into either your calculator or into WebAssign, you're not going to be able to do this exponent notation. Instead, we would replace times 10 with the letter E. So this number then would look like 5.362 E11. Take a moment to convert this number into scientific notation. You should have ended up with the number 2.4001 times 10 to the power of positive 7 because we needed to move our decimal 1, 2, 3, 4, 5, 6, 7 places. And again, if we needed to express this number in either calculator or WebAssign notation, it would have been 2.4001E7. When we go and express very, very small numbers in scientific notation, the process is very similar. Again, we are looking to move our decimals so that it is between the first and second non-zero digits. So we would be moving it to this place, leaving me with a coefficient of 3.28. And once more, I will be multiplying it by a base of 10. And now I need to find my exponent. So again, I count how many places I moved my decimal. In this example, I moved it 1, 2, 3, 4, 5, 6, 7, 8 places. But because this is a small number, I moved it in the other direction. So my exponent would be negative. And once more, I can express this using that lowercase e notation that your calculator and WebAssign would require, leaving us with an answer of 3.28 e negative 8. Take a moment to express this example in scientific notation. We should have ended up with the number 1.40 times 10 to the power of negative 5 because we moved it 1, 2, 3, 4, 5 positions over, or 1.40 e negative 5. If we take a look at these examples, here we see we're going in the other direction. This time we're given a value in scientific notation. We want to express it in standard notation. If I take a look up here, we see that I have a value of 3.251 times 10 to the power of 6. And because this 6 is positive, that means my number needs to get bigger. Therefore, I will be moving my decimal to the right. So I start by moving it by writing my 3.251, and then I move it 6 positions. positions, and now that I've run out of numbers, I will fill in the rest of them with zeros. So I still have 3 more positions that I will fill in, and each of those positions becomes a 0. This leaves me then with the following number: 3,251,000. Take a moment to express this value in standard notation. Again, I have a positive exponent, which means my number needs to get larger. Therefore, I'll be moving my decimal to the right, and I will be moving it to the right 3 places. So I would move it 1, 2, 3 places, and this is where my decimal will now be placed at, leaving me with the answer of 9,908.1. Down here in these two examples, again, we're going from scientific notation into standard notation, but this time my exponents are negative. Therefore, when I go to move my decimal, instead of moving it to the right, I will be moving it to the left. So I again start with my number, and then I begin moving my decimal. So there's one place, and again, now that I've run out of places, or now that I've run out of digits, I'll use zeros to fill in the remaining. So there's my last 2 places, there's my decimal, and I'll fill in those spots with zeros. This leaves me then with the answer of 0.00913. Take a moment to express this value in standard notation. You should have ended up with the answer 0.0000144 because I needed to move my decimal 5 places to the left. So here's my first place, and my next 4 I would fill in with zeros. When trying to determine number of significant figures for a value expressed in scientific notation, we only need to look at the coefficient. The coefficient may contain middle zeros and may contain ending zeros. If an ending zero is present, as in the case here, there is a decimal present making it significant. Note that any value written in correct scientific notation will never have a leading zero. Therefore, all digits, including all zeros expressed in correctly written scientific notation, will always be significant. Therefore, you count the number of digits in the coefficient, and that's the number of significant figures. So in this first example, I have 3 digits, meaning in my coefficient, meaning I have 3 significant figures. Take a moment to figure out the last 3. You should have come up with 4, oops, not 4. You should have come up with 2, 4, and 3 significant figures for each of them.